Yeah, I just wanted to share with you something I was working on, I'm thinking about, and what this is going to be is this is going to be a two-axis add-on to a three-axis machine or a two-axis machine. This is the start of something I think will work, and I'm trying to figure it out as I go. And what I got here is it's 6.5 inch diameter, 6.5 inch diameter here, and it's like a gimbal. It's going to move back and forth, and these pads on the side are going to be where I'm going to mount bearing plates, probably some kind of Timken tapered roller bearings, and there's going to be a piece on the top which is going to be where the table mounts on the top. I was thinking about a table like this, T-slot table, and it's going to mount on top through this series of holes here. Now it's just going to use these 3 here and 3 on this side, and this is a dowel pin hole, that's a dowel pin hole, and but this hole in the middle is for a tooling ball. So that's going to mount on top. Of course, there's a plate that there's another piece that goes on top of here first. So what this essentially is this surface here is a bearing surface, and the table is going to ride on that, against that, and it's going to ride on this surface here. And this surface here, there's going to be a tooth belt that rotates this. Now in the center here is where I'm going to mount a motor, little stepper motor. These are the four holes for adjusting it. Going to be a little little wheel on top of the motor. I thought I had one here. Oh, here it is. Going to be a little wheel on top of here. That's going to move back and forth for the adjustment. Little toothed that's what these slots are for. This is a passageway for the belt, and these pieces on the side is going to be a bracket to put on top of the motor to help stabilize it, because I don't want all the force trying to bend that shaft. I'm going to put a little bearing on top, stabilize it. Then this slot here is going to be for another tooth belt. It's going to make it go back and forth like this. So it's going to sit in a horizontal position, Now you can tip it up 90 degrees. So if you wanted to work on the, then it would rotate here. So if you wanted to work on the outside of it, and there's another cavity in here for the another motor. So what's unique about this one is that the servo motors are inside the unit. They're not external. And you won't need any kind of harmonic balancer or any kind of reduction gearing or planetary gearing or anything like that. It's going to be very, very simple, hopefully effective. And my original plan was to kind of get this thing drawn up and then I was going to have it, I was going to print it on my 3D printer. Now the thing is that in order to put the stuff inside of here, you basically have to cut it in half and then print one half, print the other half, and then fasten these two halves together. That's the only way you're going to get the stuff inside of there. And what I was finding out was that when I went to put it in the 3D printer, it said it would take almost 20 hours per half. It's almost 2 days to print this whole thing. And the thing was that I didn't really have it finalized. I'm still, working on the design of it. So I didn't want to waste 2 days of printing it just to find out if it worked or didn't work. I'd rather go ahead and try to get some kind of final design on it and then print it out and then see what it looks like. And then figure out how exactly to make it out of a stronger material. Now these bores in here, they're for bushings, so that when the motor, see, there's going to be a motor here, and this is the other cavity for the motor that goes on top. This is the motor for the top. This is the motor for the side. Let me try to get a side view. Yeah, there we go. Really hard to tell. But this is a there's going to be a pulley here. There's going to be another pulley here. This is the motor back here, and it's going to drive this pulley over here, which is going to go over here and drive that belt. Now this is going to be a 1-to-1. This is where the motor goes in the back. This is a bearing bore to support the front of the shaft. Like I said, there's going to be some type of bushing in here. Now what this little slot is for, you see the belt's going to be in here, and there's going to be really no way of adjusting that belt. It's basically fixed. You got the 4 mounting holes here, and you got the other pulley here, so there really is no real means of adjusting that motor. So I put a slot in here in the bottom, this slot right here, and I'm going to I can put a shaft in there, a square shaft with a bearing on it, so it pushes against that belt, and that's how I adjust that belt. If it's a little too much slop in it, there's a little, put that shaft through there and put a little tension on that belt. Now I know it's a little confusing right here looking at it for the first time, but it's you know, I've been working on this for a couple weeks, and I'll probably be working on it a little bit longer than that too, a couple more weeks. But you know, keep you updated on this. So this this is the part that's going to sit on top of there. And then the table gets mounted on these holes here, and this surface here is what that ring rides against, that bearing ring. Well, I won't call it, well, it's not a bearing, but it's a bearing surface. But as far as that table, I might make that round. I really like that shape. But I might end up making it round. And these grooves, they're not, you know, they're the small grooves. You know, like on the front of a Bridgeport, they got that little slot in the front for where you mount your stop if you have a electric motor, and they're not very big. It's a 7/8 by, I think it's 1/4 inch. Yeah, 300. Yeah, 1/4 inch for a little T-slot. But anyway, that's something I'm working on, and we'll see what happens. So I just thought I'd throw that out there. Yeah, on this part here, I'm still working on it, and then we'll get it printed and see what it looks like. That's the cavity for the top motor. This is where the other motor goes. This is where the belt's gonna go. Now when I get this stuff in, I ordered the stuff. You know, I'm not sure how it's gonna work, but I ordered the parts, and then I'll print this thing out and we'll put the pieces together and see how it works out. But I'm pretty confident. Of course, I got the frame. You know, I got some frame. I got some 2x2 square tubing frame. That's going to be the base for this to rotate against. And I'm working on some mounts right now. And eventually, when I get this look like it's pretty good, I'll go ahead and spend the time and print it out. Now that the guy out there, Cloud 42, he shows this like it's aluminum plastic. It's some kind of metal they put in the plastic for the 3D printer. Now that might be an option to just go ahead and print it with that. Of course, I won't do that at first. I'll just use the regular, what is it, PLA or something like that. This is the cheap plastic stuff. Because this other plastic he's talking about, I think it's like $150 or something for a roll of it. Then you got to get these special nozzles and all this and that. And, you know, I don't mind doing that if I figure out this thing's going to work. I mean, I'll put it together and I'll see if it works. And if it works and it just needs to be, you know, made out of stronger material, I wouldn't mind spending the money for that. Have something. But we'll see how it goes. This is a first of many. Alright. Talk to you later. Bye.